Introduction to V-Ray for 3ds Max. This is our biggest course ever here at Mograph Plus, and we spent almost 4 months working on this course. In this course, in more than 17 hours or 1030 minutes of high quality and academic video tutorials, we explore one of the most popular render engines, which is V-Ray from Chaos Group. Our ultimate introduction to V-Ray for 3ds Max is without a doubt the most detailed, high quality and academically approached course on V-Ray up to now. The videos are categorized into 9 sections. In section 1, we give you a general overview of V-Ray in 3ds Max and its user interface. Section 2 will be all about lighting. We go through all the lights that V-Ray offers. We explore V-Ray area light, mesh and dome light, V-Ray sun and sky, IES light. We'll learn how to use standard 3ds Max lights with V-Ray and learn about V-Ray lighting tools like V-Ray Light Lister. And we'll literally explore every single option and light and parameter with practical examples and visualize how they work. In section 3, we talk about global illumination or indirect lighting. First, we'll learn how light rays work in real world and how V-Ray simulates the same behavior using global illumination. Then we start learning about all the GI engines that V-Ray has, like Brute Force, Radiance Map and Light Cache. We learn how to use these engines in different lighting scenarios to produce the most realistic lighting possible. We explain every single available parameter in the GI tab of V-Ray settings with actual examples, and we finally learn how to render flicker-free animations with global illumination. Section 4 will be dedicated to the very core of V-Ray, which is image sampling. First, we'll learn the basic concept, and then we'll learn about bucket and progressive image sampler, global DMC options, image filters, and render masks. Section 5 is all about V-Ray materials, and this is the longest section of the course, and we spend more than 5 hours in 17 lessons explaining all the materials and maps that V-Ray has to offer. We start this section with V-Ray material or V-Ray MTL, and as this is the most important V-Ray material, we spend more than 1 hour explaining this material. Then we talk about bump and displacement mapping, blends material, two-sided, subsurface scattering, skin and carpent material. We learn about hair material, override and wrapper materials, and finally go through all the remaining materials and maps that are included in V-Ray. In the next section, we'll learn about cameras and camera effects in V-Ray. First, we explore physical camera in depth. Then we'll learn how to produce and adjust effects like depth of field and motion blur. We'll learn about different camera types in V-Ray. Then we explain stereoscopic 3D rendering and lens effects like bloom and glare in V-Ray. Unlike other topics, after watching these sections, you should be a master of handling your camera in V-Ray because everything has been explained in extreme details and based on academic approach. In the next section, we go through the remaining render settings. First, we learn about color mapping and why it is so important in forming your final image. Then we talk about V-Ray virtual frame buffer, global switches, environment rollout, how to produce and adjust caustics effect in V-Ray. We talk about more technical and advanced settings in the settings tab of V-Ray. We learn how to use V-Ray RT to interactively render and adjust our scene in real time. Then in the longest lesson of the course, we discuss and explain V-Ray render elements or render passes. We go through all the render elements and learn how to generate different render elements and what each one adds to the final render. Then we'll learn how to composite those render elements using an external application like After Effects. And finally, in this section, we take a look at V-Ray quick settings, which allows you to control the overall quality of your render in a very simple and user-friendly interface. In section 8, we'll learn about V-Ray geometries, including V-Ray proxy, V-Ray first, section clipper, and other geometries. In the final section, we discuss atmospheric and volumetric effects in V-Ray. First, we'll learn about V-Ray environment fog and explain all of its options using visual examples. Then we'll learn about aerial perspective, toon render effect, and in the final lesson, we'll learn about V-Ray volumetric grid, which allows us to import grid-based cache formats like OpenVDB and render them using V-Ray. First, we'll learn the basics, and after that, we import several OpenVDB files and try to adjust their shaders and settings to produce some exciting explosion, fire, and and smoke effects. The ultimate introduction to V-Ray for 3ds Max is the biggest course we have ever produced, and we are very proud of that. The course was recorded in 3ds Max 2017 and V-Ray 3.4. We plan to keep this course alive and update the course with more video tutorials as soon as a new version of V-Ray is made available by Kiosk Group. Hell, we are already planning to record a series of video tutorials as an update for this course when V-Ray 3.5 comes out. The thing about this inclusive course is there is a plan for every single moment of it. We literally wrote down scripts for each and every single lesson of the course. That's why I like to think of this course as 1030 minutes of pure and premium knowledge. So there you have it. If you are looking for a detailed, academically approached, high quality course on V-Ray for 3ds Max, I promise you absolutely cannot find better than the ultimate introduction to V-Ray for 3ds Max by Mograph Plus. My name is Kamel Khezri from mographplus.com, and I'm honored to be your instructor for this course. So sign in or sign up and let's get started. Welcome to the course and thanks for purchasing this one. After you finish downloading and extracting your files, you should find all the video tutorials. For each section there is a folder. You go in there and watch all the videos for that particular topic and section. You can also find the project files folder. If I go in there, we have a typical 3ds Max project structure. In the scenes folder, you have all the 3ds Max scene files for all the lessons. For example, if I go to section 5, materials, for most of the lessons we have two files, a start and a finished 3ds Max file. The start version is basically the raw file without any changes made by me, and the finished version contains all the changes that I have done on that start file during the recording of that particular lesson. In the scene assets folder and images folder, you can find all the textures that was used in this course. In the render output folder, you can see we have the same folder structure, and here you can find the final renders of the lessons and some other things that I will mention during the videos. For example, the final renders for the volumetric grid lesson, which is the last lesson of section 09, can be found in section 09, lesson 0904, final render folder. And there we have all the final renders for that particular lesson. Or if I go to lighting section, lesson 0205, which is about V-Ray sun and sky, in the final render folder we have all the final renders for this lesson too. You can see there is a history folder for all of these lessons, and they are all empty. As I mentioned several times during the course, I was actually planning to include all the renders that I have done during recording these lessons to show and compare different parameters in the project files for you guys, but as I was kind of preparing the files to upload, the overall project file size would have been huge if I included all the renders that I have saved to the V-Ray history window during recording the course. Also, I realized they wouldn't be that important because I go through all of those renders during the video tutorials anyway. All the models or textures used in this course are made by mographplus.com or properly licensed to be redistributed by mographplus.com through this course and cannot be used elsewhere commercially. If you own the right for any of these models or textures and you think we have licensed them through the wrong person or organization, please feel free to contact us at info@mographplus.com. Now let's go ahead and get started with the course. I'll be starting this course using 3ds Max 2017 and V-Ray version 3.4.03. As soon as a new release of the plugin is available during recording this tutorial series, I'll be switching over to that particular release and I'll make sure to inform you if it happened. Now, just to make sure we are on the same page, I'll be using the academic version of V-Ray in this course. If for any particular topic I use the commercial license, I'll make sure to let you know. But you don't need to worry about that because the features are pretty much the same no matter what license I use. In this lesson, we take a look at how to set V-Ray as your render engine and how it integrates with 3ds Max's user interface. Basically, where you can find different V-Ray tools and options in 3ds Max. One of the first things to integrate V-Ray with 3ds Max is to go to your Customize menu and click on Custom UI and Default Switcher and select max.vray as your default option and click on the Set button down here. Now you might need to restart your Max session to make sure the changes are applied to the UI and default settings. I've already done that. By doing so, now V-Ray is fully integrated with 3ds Max UI. You don't have to do it, but if you do it this way, V-Ray is going to be a lot more useful. Now, for example, whenever you start 3ds Max, V-Ray is set as your render engine. If I open up my, for example, material editor in the compact mode, all the slots are occupied with V-Ray materials and so on. Now, V-Ray actually includes two renders, V-Ray and V-Ray RT. If you go to your render setup window by pressing F10, in the render dropdown, you notice you have two V-Ray render, V-Ray EDU and V-Ray RT. EDU stands for educational. That's because I'm using the academic version of V-Ray. If you are using the commercial version, you would see V-Ray ADV or ADV, which stands for V-Ray Advanced. This is basically the main V-Ray render, the one which supports all the features of V-Ray, and you would use it for rendering your final image. On the other hand, you have V-Ray RT or V-Ray Real Time. This is an interactive preview render. For example, if you are working on your lighting or shading, whatever changes you make, you can see the results in real time, which is an extraordinary helpful feature and makes the process quite a lot faster. But it doesn't support all the V-Ray features. We will be discussing V-Ray RT in depth in one of our upcoming lessons. The normal workflow is to use V-Ray Advanced or Educational as your production renderer, then switch your target to active shade mode and set V-Ray RT as your active shade mode. You can use V-Ray RT in both production and active shade mode, but V-Ray Advanced or Educational can only be used as production renderer. Let's take a look at the UI and see where you can find different V-Ray tools and options. After you set V-Ray as your render engine in the render setup window, you see all of these new specific V-Ray tabs. Here is where you control the quality of your render and image sampling. You control the global illumination, alternate different V-Ray settings, and set up your render elements to work with them in an external compositing app like Nuke or After Effects. The next major UI element is V-Ray toolbar. I have it docked on the left side of my interface. You can simply undock it by clicking and dragging it and dock it wherever you want. This toolbar includes the most used V-Ray tools and options. So basically tons of hidden V-Ray tools and options in the menus or panels are simply exposed here, and you can use them without having to go through different menus, which is very, very useful. I'll be discussing this toolbar in another video. Right now, just let me go briefly and introduce some of the buttons here. Up here we have render current frame in the production mode. If you click and hold, also you can see we have the render current frame in the active shade mode. Okay. Next we have last VFB, which is going to show you the virtual frame buffer window and your last render. I will be discussing this window in one of our future lessons. Next we have V-Ray render settings, and then we have V-Ray quick settings window, which allows you to quickly and easily adjust your render setting without having to deal with the complex interface of the render setup window. Next we have V-Ray light lister, which lets you to see and adjust all the lights that you have in your scene. We have the ability to create different types of cameras down here. We have the ability to create different V-Ray lights. Then you have V-Ray proxy, V-Ray metaball, V-Ray plane, V-Ray displacement modifier, V-Ray fair, V-Ray hair farm, and or matrix modifiers. You can create V-Ray material and V-Ray VR matte material. You can register the V-Ray menus, and also by clicking on the V-Ray help button, you can go to the V-Ray official documentation and help. If you take a look at the menus, you will find some V-Ray related options and items. In the Tools menu, we have the V-Ray Light Lister and V-Ray VR Matte Converter. In the Create menu, you can create different V-Ray objects and V-Ray lights and different V-Ray cameras. In the Modifier menu, you have access to different V-Ray modifiers. And in the rendering menu, you got the Make V-Ray RT Animation preview. If for whatever reason you can't see these V-Ray specific menu items, please make sure to click on the V-Ray menu registration button in your V-Ray toolbar. Also in your commands panel, in the Create panel, you can create different V-Ray objects and V-Ray lights and V-Ray cameras. In the Modify panel, you have access to different V-Ray modifiers and so on. Another major V-Ray component is going to be your V-Ray materials and maps. So if I press M to open up the material editor and make sure I am in the Slate material editor, on the left side you can see we have different V-Ray materials, and down here we have V-Ray maps. I can right click here, create maybe a V-Ray material, double click on its name and start editing it. So in this lesson we talked about how to set V-Ray as your render engine and what is the difference between V-Ray and V-Ray RT. We'll learn about user interface and how V-Ray integrates with 3ds Max. See you in the next lesson. In this section, we start discussing lights and lighting in V-Ray. In the Create panel and Lighting tab, if you select V-Ray, you can see all the different lights that V-Ray has to offer. In the first few lessons, we're only going to discuss the main light type, which is V-Ray Light. If I click on the V-Ray light, you can see that it includes different area lights like plane, disk, sphere, mesh, and dome. In this lesson, we are going to talk about plane, disk, and sphere types. Plane light is your normal square or rectangular area light. This is the light that you're probably going to use it 80% of times. Now, before creating our first light, let me quickly walk you through the scene. First of all, I have this clock and this very simple plane object that's going to work as our floor, and obviously a 3ds Max physical camera. Also, if I open up my render setting and go to the GI or Global Illumination tab, you can see it is enabled. Now, you don't need to know what GI is right now and what these parameters are doing here. You only need to know that GI makes our lights work more realistically, and having it enabled makes our light rays to bounce around basically. So let's create our first light. You can go to your commands panel and create it from there, or simply use V-Ray toolbar. In the toolbar, click on the V-Ray plane light and start clicking and dragging the light, in this case in the left view. In the top view, I'm going to move the light a bit to the left side. Also, let's change our left view to perspective view. One of the things you can do to make the positioning of your light easier is to enable the targeted option in your V-Ray light. If you go to the Modify panel, and if it's not enabled, you can enable it. Now select the target and try to position it as close to your main subject as you can. Now select the light and position it as you wish. The exact position that I want for my light is -81, -100, and 36 on X, Y, and Z respectively. Let me go to my render settings and change the target to active shade mode and make sure that V-Ray RT is our render. Now I want you to go to V-Ray RT tab and enable undersampling. When undersampling is enabled, V-Ray RT starts the rendering at a lower resolution in order to speed up the initial preview, and now you can click on the render button. Okay, this is our initial render. To speed up the process, we can override all the materials in the scene. Let me stop my active shade. In the render setting window, enable override material. Click on this None button and select V-Ray MTL and click OK. Now, all the materials in the scene are going to be rendered with this simple gray material. Let's copy this material, change the target to production rendering mode. In the V-Ray tab down to the global switches rollout, enable the override material here and paste instance the same gray material. Now let's get back to the active shade mode and click on render. Select your light and go to the modify panel and see what we have here. First, you can turn your light on and off, and you can see the result in real time in the V-Ray RT. Then we have type drop down, and as you can see, we have plane, dome, sphere, mesh, and disk type. We'll be talking about all of these area light types and shapes in this section, but for now, let's focus on the parameters of the plane light. First, we have targeted, which creates a separate target for the light and allows you to point and direct the light source a bit easier. A few moments ago, we actually used this function to position our light around our subject. Then we have half length and half width, which control the size of our light. So let's set these to 40 and 40, and as you can see, suddenly the scene is a lot brighter and the shadows are a lot diffuser. Now let's set the half length to 8 and width to 13. And as you can see, now we have a darker scene and sharper shadows. I'll be getting back to this important topic of how the size of the light relates to its brightness and shadow sharpness in a moment, but to fully grasp the concept, I need to discuss different units that you can control your light intensity or brightness with. First, we have default units, which is very generic. In this unit, the intensity of the light depends or relates to the size of the light. So if I double the size of my light, you can see we get a brighter scene. Next, we have lumens, which in this unit, the emitted visible light will be measured in lumens. In this unit, the size and intensity of the light aren't related to each other. So if I increase or decrease the size of the light, as you can see, we have the same intensity. And the only thing that is actually changing right now, whether the shadows are getting diffuser as we increase the size of the lights or getting sharper as we decrease the size of the light. Now, next we have lumens per square meter per sterdian. And in this unit, size and intensity of the light relate to each other. Then we have a radiant power or watt. In this mode, the emitted light will be measured in watts. In this unit, size and intensity of the lights do not relate to each other. Finally, we have watts per square meter per sterdian. In this unit, obviously, size and intensity of the light relate to each other. Now let's use watts as our unit and set the multiplier to something like 10 watts. A multiplier basically controls the overall light and color intensity of the light. So if I increase it to something like 40 watts, you can see the light is a lot brighter. And if I set it to something like 2, it gets a lot darker. Now let's here set it to something like 10. Now remember, a normal 100 watt light bulb only emits about 3% of that power as visible light. So here when we use something like 10 watts as our multiplier, we are having the equivalent of about 3 100 watts light bulbs. Before going through the rest of these parameters, let's quickly talk about the relationship between the size of the light and its shadows. As the light gets larger, its shadow becomes diffuser, and as it gets smaller, the shadow is getting sharper. Now let's see it in our V-Ray RT. Let me first use a small size like 4 and 7. And as you can see, the shadow is very sharp. Now, let me increase the size to something like 24 and 39, and as you can see, the shadow is a lot less defined and basically it's diffuser. Now remember, even though we have increased the size of our light, the scene didn't get brighter. That's because when the unit is set to watt, the size and intensity of the light do not relate to each other. Let me change the size of the light to 8 and 13. Then you have two modes to control the color of your lights. In the color mode, you simply select the color from here, and you can see the changes in the V-Ray RT as I'm kind of changing and using different colors. And in the temperature mode, the color of the lights can be determined by using a Kelvin value. By default, it is set to 6500 and you get this white neutral color. A lower number, like let's say 3500, will give you a warmer, more reddish color, and a value higher than 6500, like for example 10,000, is going to result in a color, cooler, more bluish color. Now in this case, let's set this to something like 6500, which is the default value. Now next we have texture. If you enable this checkbox, you can specify a texture to be used as the color of your light instead of the above color options. Now before that, let me create a copy of this physical camera that we have. Press C and make this second camera your active camera. Position it in a way that enables you to see the light source itself and make sure that V-Ray RT is running. Now select the light again. Click on this None button to define a texture. You can select any map or texture, but there is a specific map in V-Ray that can help you resemble real-world softboxes, and no surprise, it's called V-Ray Softbox. So select V-Ray Softbox, press M to open up Material Editor, and let's drag this map to our active view. Double click on it to select it. If you come down, you can make the softbox to have a frame and a U vignetting. And as you can see, the softbox is quite visible on our light surface. And also it will be visible in our reflections. Now let's stop V-Ray RT and close these windows. Let me also untick this texture checkbox. Next we have this resolution option, which controls the texture resampling for the specified texture down here when MIS or multiple important sampling is enabled in our advanced option rollout. We will talk about MIS later. Let's continue with the rest of the options. Next, we have our rectangle disk light rollout. As the name suggests, this rollout is only available when the light type is set to plane or disk. Let's get back to our main camera and make sure V-Ray RT is running. Using the directional option, you can make your light to be more focused and directional. As I increase the directional value towards 1, the light becomes more directional, and at 1 we have a fully directional light. Now we can use some fun textures to control our light. So for example, I can get back up to my general rollout, make sure I have a square light, maybe 13 and 13 or something like that. Enable the texture checkbox, click on the texture button, and from the general section select bitmap and select this window.jpg texture. Okay, and now if I use a multiplier like 5 or 6, you can see we have a pretty dramatic effect. Obviously, this is just a proof of concept, and you can use more complex lighting and get better results. Now let me uncheck the texture checkbox again and change the half length to 8 and half width to 13 and set the multiplier back to 10. Then we have this preview dropdown, which helps to preview the effect of the directional parameter in the viewport. By default, it is set to never, so we cannot see any preview of the effect in the viewport. But if you change it to always, you can see a 90-degree light cone in the viewport. And as I decrease the directional value, the light cone becomes wider and basically less directional. When it is set to always, you can always see the preview whether the light is selected or not. You can change it to selected, and this way the preview is only visible when the light is selected. Okay, let's zero out the directional value and change the preview mode to never. Great, next we have the option rollouts. First, we have the exclude include window, which allows you to exclude or include specific objects in the illumination and shadow casting of the light. For example, I can double click on the floor object and exclude it from this light, and you can see the result in V-Ray RT. Let me double click on the floor again and remove it from the list. Then we have cast shadows, which controls whether the light casts shadows or not. Next we have double-sided. First, let me switch to my second camera and position it in a way so I can see the backside of my light. Right now, as you can see, the light only emits from only one side. That is because the double-sided checkbox is unticked. If I enable it, the light emits from both sides. This option only works with the light types that can have clear front and back side, so only plane and disk types. Let me disable this option and move my second camera in a way so I can see the light's front side. We have invisible, which controls whether the light source is visible or not. Right now we can see the light source in the render, but if I enable it, now the light source is gone, but the light still affects the scene. We only can see the light source when seen through the camera or refraction. So if I had a refractive object like a glass, for example, in front of my light, I wouldn't be able to see the light through it when the invisible option is enabled. But the light source still can be seen in the reflections. Let me show you that quickly. In the render setting window and V-Ray RT tab, disable the override material functionality and get back to the main camera. Now, as I am enabling and disabling the invisible option, you can see it is still visible in the reflection and specular highlights. The visibility of the light in reflections is controlled by this option down here called effect reflection, which we will discuss it in a moment. Now, let me enable the override material in the render setting again. Also, let's get back to the second camera. Next, we have no decay. As you can see by default and also in real world, the surfaces that are closer to the light source are going to be brighter, and as the surfaces gets further away from the light source, they become darker. But if you have no decay enabled, the intensity and brightness of the light will not decay with distance. Let's disable it here. Next, we have Skylight Portal and Simple. These are two very specific options, especially for interior lighting, and I'll be discussing them in a future lesson. Let me get back to the main camera. The next option is Store with Irradiance Map. Now, Irradiance Map is a method or algorithm to calculate GI. If I go to my render setting and change my target to production rendering mode, and go to the GI tab, you can see one of the GI methods is Irradiance Map. When Store with Irradiance Map is enabled and Irradiance Map is being used as a GI method, V-Ray is going to calculate the effect of light in the Irradiance Map, and the result would be basically a faster render but with less defined shadows and details in the lighting. Now, if I open up my frame buffer, I have two renders, with and without the Store with Irradiance Map option enabled. As you can see, when this option is enabled, the shadows are less defined in comparison with when this option is disabled. And also, we have some problems seeing specular reflections in the version with Store with Irradiance Map enabled. Let me disable this option. Now, the Store with Irradiance Map option is useful when, for example, you have a secondary light, something, for example, like a fill light, and you don't need that much detail in the shadows that are casted by that particular secondary light. So in that case, you can enable a Store with Irradiance Map for that particular light and see the render goes a bit faster, and you get basically the same result because the shadows aren't gonna be that defined anyway. Now let me disable this option here. Now let me close the frame buffer and open up the render setting. Change the target to active shade, and in the V-Ray RT tab, disable override material and heat render. Next we have effect diffuse, effect specular, and effect reflections. When effect diffuse is enabled, the light affects the diffuse portion of the material in the scene, and if I uncheck it, the light only affects speculars or highlights and reflections. Let's enable it again. The value here controls how much the light affects the diffuse contribution of the material. I can increase and decrease this value and you can see the effect. We have effect specular, which determines whether the light affects the specular contribution of the materials or not. And effect reflection, as we talked about it beforehand, controls whether the light is visible in the reflections or not. Next, we have the sampling rollout. The first parameter is subdiv or subdivisions, which is grayed out by default. This parameter controls the quality of the light, how many sample basically V-Ray uses to calculate the effect of the light. In order to be able to basically tweak this parameter, you need to go to your render settings and change the target to production rendering mode. Go to the V-Ray tab down to the global DMC rollout and enable use local subdivs. Now, to see the effect of this subdiv parameter a bit better, let me go to my image sampler rollout and make sure the UI is set to expert mode. so we can see all the parameters and options. Turn off divide shading subdivs and set the minimum shading rate to 1. Also in the bucket image sampler rollout and global DMC rollout, I'm going to change my noise threshold to 0.03. I'm altering these parameters simply to be able to present the subdiv parameters of the light a bit better. Okay. Now we're going to be discussing these parameters and these tabs and all these settings in their specific lessons, so no worry about that right now. As I mentioned, I'm just trying to be able to present the subdiv parameters of the light a bit better. Great. Now let me show you 3 renders with subdiv parameter of the light set to 1, 8, and 64. This is the first render with subdiv set to 1. This one is set to 8. And the third one is set to 64. If I zoom in here using my scroll and compare the 1 and the 64 version, you can see clearly the version which has the higher subdiv is cleaner. Let me set the 1 version to A and 64 version to B and compare them. You can see clearly the B side is a lot cleaner. Let me get out of the comparison mode and set the subdiv of the light back to 8, and in the render setting you can set the noise thresholds to 0.01 and 0.01. Also you can turn off use local subdivs, enable divide shading subdiv, and set the mean shading rate to 6. Change the target again to active shade, and in the V-Ray RT tab, enable V-Ray override material. And now you can basically start the render again. The next parameter is shadow bias. This parameter basically moves the shadow closer or farther away from the object. So if I increase this value, for example, to something like 2, you can clearly see the shadow is moving. And let me set this back to 0.02, which is the default value. Then we have cutoff, which is the threshold below which the effect of the light won't be taken into consideration. For example, if I set this value to something like 0.4, if at any point the effect of the light is less than 0.4, V-Ray wouldn't calculate that light anymore. And as you increase this value more and more, the cutoff point is getting closer and closer to the light source. Let me set this value back to 0.001. Okay, let me close all of these windows here. Next we have some very basic viewport options. Enable viewport shading lets you see the effect of the light in the viewport if you are in a mode like high quality. Now if you want to change the wire color of the light in the viewport, you can use viewport wire color option. And you got the icon text, which lets you see the name of the light in the viewport. In our advanced option, we have use MIS or multiple importance sampling. If I want to loosely explain this option, is that it helps the secondary rays to find the light sources a bit easier in the scene and focus on them. I'll be going over this option when discussing mesh and dome light, but for the time being, I'm just gonna show you these 2 renders with and without MIS. In the first render, MIS is enabled, and in the second one, it is disabled. As you can see, when we disable it, some areas like these edges here are getting noisier and less clean. I'll be showing you a few more examples in the dome and mesh light lessons. Now, let me get back to my second camera and enable my active shade. Now, if I go to the general tab of my V-Ray light, in the type drop-down, we have 2 other light types that I want to discuss in this lesson very quickly. First is disk light, and as I change the plane light to disk, you can see now the area light has a different shape. And also you get a parameter called radius to adjust the size of the disk, and I can try a radius maybe of let's say 2 and 8 and 16. And as you can see, as I'm increasing the radius, the shadow becomes more diffuse. Let's set it back to 8. Next we have sphere, and as I change it now, the light shape is a spherical shape. Maybe I can move my camera a bit so you can make sure it's a sphere. Also, here you have this kind of radius parameter to control the radius of the sphere, and as you notice, by changing the type to sphere, the rectangle disc rollout has disappeared. Let's change the light type to rectangle and get back to the main camera. Great. Basically, this lesson is finished, and you can skip the rest of this lesson and maybe come back to it when you finished watching all the tutorials in the lighting section. But if you want to continue, let's add a few more lights to our scene and make our lighting a bit more interesting. Now let me select my main light in the top view, hold down Shift and create a copy. Let me adjust the position a bit. Now this light is going to work as a fill light. I don't want to see those very dark shadows caused by the main light. Also, it's going to add some nice reflections on the clock. In the modify panel, let me increase its half width to maybe something like 45. Let's run the V-Ray RT and see what we got. As you can see, it's very bright, so I'm going to decrease its intensity to something like 2, and no, it's a lot better. If I select the second light and turn it on and off, you can see how the light helps us to get rid of those very dark, nasty shadows and also add a beautiful reflection on the clock. Now, the reflection on the glass part of the clock is not very interesting. You can see it's very sharp. So what I want to do is to use a very soft box as the texture for this light. If you remember, we created a very soft box texture early on in this lesson. So let's open up the material editor by pressing M and add that texture as an instance and make sure texture checkbox is enabled. Now, as you can see, the reflection of the light is much more interesting and realistic. Now, to make the lighting a bit more interesting, I would like to add a dome light. Now, obviously, we still haven't talked about that type of light, and you can skip this part and get back to it after we discuss dome light. But generally speaking, it's like a virtual sky. So let's just create a V-Ray dome light from the toolbar. Click on the V-Ray dome light icon and click wherever you want in the scene. Go to the modify panel and click on the texture button. This time we are going to use a V-Ray HDRI map. Let's load this HDRI. Now open up the material editor and drag the V-Ray HDRI to the active view. I just want to desaturate this map a bit, so let me right click in an empty space and add a color correction map from general category. Now hook it up with the V-Ray HDRI, select the color correction map and desaturate the input map by about 25. Now we can use this map as the texture of the dome light. So let's do that. As I don't want this light to affect my scene that much, I'm going to select the V-Ray HDRI map and set its override multiplier to something like 0.3. Great. Let's see the result in our active shade. Now let me turn this light on and off to see how it affects the overall lighting. Maybe it's a bit too bright, but I know I'm going to color correct it quickly, and this dome light is gonna add a lot to the final image. If I go to my second camera, here you can see the effect of this dome light quite a lot better. Great. Now let's get back to our first camera and stop the active shade. In the render setting window, change the target to production rendering mode. And in the render element tab, I'm going to add a render element called V-Ray denoiser. This element helps us to get rid of any high frequency noise in our render, which is great in this case. Click on the Add button and select V-Ray denoiser. And in the Common tab, change the resolution to something like 1200 and press Render. Great. I'll be back when the render is finished. Now the render is finished and this is what we are going to get. Also, we have our V-Ray denoiser pass. I can take a look at it, and as you can see, it's quite cleaner compared to our RGB color pass. It's a bit washed out, and as you probably know, every raw 3D render needs to be color corrected. Thankfully, we have some color correction tools built in V-Ray Frame Buffer. What you need to do is to simply click on this icon that says Show Correction Controls. Let's enable our curve correction and add some contrast to the render. Then enable white balance. I'm trying to get a bit warmer render, so I'm going to cast out some of the bluish tone by increasing the temperature to something like 7600, and there you have it. And now you can save this image and open it up in Photoshop and apply your color corrections there too. Great. In this lesson, we talked about V-Ray light in its plane, disk, and sphere shape. I will see you in the next lesson. In this lesson, we cover skylight portal option in V-Ray Light that we skipped in the previous lesson. That was because we actually needed another scene to be able to fully understand what this option is for. I really want to avoid one-dimensionality in this course. That means I don't want to start the lesson with fully prepared scenes and simply fire up the render and quickly explain the options. As we are working with a new scene and our topic is lighting, let's go through the basic approach of lighting process for an interior scene. And as we do so, we also learn about Skylight Portal, which is the topic of this lesson. Obviously, I'll be going through the complete process of interior lighting in one of our upcoming lessons, but here I just give you a taste. So this is the scene we are working with. As you can see, we have a simple room. It has some windows, curtains. We have this chair and this lamp, and also a V-Ray physical camera. I also have these two dummy objects so I can position the sunlight the way I've done in the preparation for this lesson. So first of all, I want you to select your V-Ray physical camera, and in the exposure rollout, make sure the exposure is set to 10. If this currently grayed out exposure control installed button is enabled, make sure to click on it to install the proper exposure control in the scene, and then make sure the exposure is basically set to 10. When you are working with an interior lighting situation, the first thing you do is to add a sun. And in the V-Ray toolbar, you can see that we have the V-Ray sun. Now select it, and in the top view, click and drag the sun in the direction that you want it to shine through the windows into the room. As I mentioned earlier, I have these two dummy objects to help with positioning and direction of the sun. The sunlight will be discussed in detail in one of the future lessons. Now, we get this message which asks us whether to add a V-Ray sky environment map or not. Basically, when you create a sun, V-Ray also wants to add a sky to the environment. And the sun and sky in V-Ray work hand in hand to create a realistic lighting for you. So I would say yes. Also in the front view, let's make sure our sun has an appropriate height. If I press 8 to open the environment and effects window, as you can see, we have a V-Ray sky map as the environment map. Great. Now I can start the render using this button in the V-Ray toolbar, which is the render current frame in the production mode. Let's start the render. Now I'm going to stop it right now. You can continue and see the results for yourself, but to increase the pace, I've already done that. So if I open up the history window, this would be the result of adding the sunlight to our scene. As you can see, the result isn't quite desirable. It is a bit darker compared to a typical daytime image. In these situations, we need to use skylight portal option of our V-Ray light to brighten the scene and help V-Ray direct more light from the environment into the room. In order to do that, we add a light to all of our windows. So make sure to enable skylight portal option, and by doing so, we have helped V-Ray to make the lighting more realistic. So let's here close our frame buffer to be able to see the windows. I'm going to double click on this container which called curtains and hide all the curtains. Now in V-Ray toolbar, I'm going to select V-Ray plane light. Make sure that vertex snapping is enabled. Now maximize the front view and zoom in a bit here. And now let's create a light based on our Windows profiles. Great, now I can unhide my curtains. Now let's go to the top view, select the light and rotate it 90 degrees. And let me here turn off snapping. And I'm just going to put the light slightly inside the room. And the next thing I want to do is to make sure that this light doesn't affect the curtains, because this light is going to help V-Ray bring in more light into the room. It would be so sad to see all that new light is going to be blocked by the curtains. So in the modify panel, even though the curtains, the materials that we have applied to the curtains are kind of translucent and allow some level of light to kind of go through them, but in this case I just want to make sure that all the light that is coming from the lights that we have just created is going to be able to enter the room. So in the modify panel, click on the exclude button in the option rollout. Now select the curtains and press OK. Now the most important thing you need to do is to enable the skylight portal option, and as you do so, you can see tons of V-Ray light parameters are becoming grayed out. You can see like multiplier, color, texture, cast shadow, and so on. That's because this light is getting its intensity and color from the environment and the objects that are behind it. So here let me create a few instances of this light and put them in our windows. Shift drag the light, make sure instance is enabled, and set the copy numbers to 2. Okay, now we have 3 skylight portals in our scene. Let's get back to our camera and see what the render is going to look like. Open up V-Ray's virtual frame buffer, and this is the render with the new lights and skylight portal enabled. As you can see, compared to our previous render, it's quite brighter and more realistic. Also, as you can see, the render time has increased by about 4 minutes, but the result definitely worth that extra time. Now, if you select the V-Ray light, you can see we have this simple option besides skylight portal option. Now, if this option is enabled, the light will only use the colors from the environment map, which in this case is a V-Ray sky and not other objects or foliage, for example, that might be behind the portal light in our environment. Let me enable this simple option here. And in the frame buffer, this would be the result that we are going to get with this option enabled. As you can see, it's not quite different compared to the previous render. That's because we don't have anything like, for example, trees or in the outside of the house to affect the lighting that much. But as you can see, the render time is quite faster and the scene is a tad brighter compared to when we only had skylight portal option enabled. Now, before wrapping the lesson, let's prepare our scene for the final render. Open up the render setting windows. In the comment tab, increase the size to something like 1200 by 1600. And in the V-Ray tab and bucket image sampler rollout, change the max subdiv to something like 50. Decrease the noise threshold to 0.007 and make sure the noise threshold in this is the same basically for the global DMC rollout as well. Now in the GI tab, change the irradiance map preset to medium, set the subdiv to something like 70, 80 and samples to 25. Now set the light cache subdivs to something like 1200. And in the render elements tab, let's add V-Ray denoiser. Now change its preset to mild so it wouldn't denoise our render that much. Great. Now let's render. Now I have rendered it before, so let's in the frame buffer take a look at what we have. It took about an hour and 40 minutes on this machine, but as you can see, the result is quite lovely. You can see here it says it took 8 minutes. That's because I had to actually re-render some parts of the image because of the 3ds Max crash that I had while rendering and combine it with the previous render, so that is not the real number. And that is the denoise version as a separate image. I use the external V-Ray denoiser tool to get this image from the render because, as I mentioned, I had to render this image in 2 phases. I'm going to show you how to use standalone V-Ray denoiser tool, which is amazing, later on. Now let me save this image as EXR. If you are trying to save it as JPG or PNG, make sure to enable the override checkbox and set the gamma to 2.2. But in this case, we are saving it as 16-bit EXR. So let's press OK. Also, let's do some basic color correction in Photoshop. You can actually close this lesson right now if you are not quite sure to follow or not, because as I mentioned, I don't want to really just explain the option and finish it. I want to just explain some processes and some workflows as I go through these lessons to make sure you understand how to finish the job and how to go through different processes and different stuff that you need to do for finishing your job. So this lesson is basically finished and we explained the concept of skylight portal, but in this case I want to continue and color correct the image very quickly in Photoshop as well, so I can give you a bit more information about that process too. Now let's open up the render in Photoshop. Okay, you have 2 options: alpha channel data as transparency or alpha channel. If you want to keep the exact look of the environment behind the windows, make sure to enable as alpha channel. And if you want to mess with the background, maybe replace the sky or something like that, you can enable as transparency. In this case, I don't want to mess anything, so let's have as alpha enabled and press OK. Now double click on the layer and unlock it. From the image menu, change the mode to 16 bits per channel. Great. Now let me duplicate the layer so I can have a copy of the original image. Rename this layer to original. Now select the other layer. From the filter menu, choose camera raw filter. And let's quickly adjust the render here a bit. change the white balance to a warmer temperature, like maybe 7, 10, 5, something like that, and add a bit of contrast, maybe something like 50. Okay, that would be enough. I don't want to really go through all of these options. It's just going to be some basic color correction, and maybe we can go through more advanced color correction in the upcoming lessons, but for now that would be enough. Now let's duplicate the layer again and apply a Gaussian blur with a radius of around maybe 5, something like that, and press OK. Now change the blending mode to soft light and the opacity to maybe 25%, and that would be our basic final color graded image. Now you can go ahead and save it as JPG or PNG or whatever format that you wish. In this lesson we talked about Skylight Portal and learned how to use it in an interior lighting scenario. In this video we talk about mesh light. Basically, a mesh light turns an object to a light source. We are going to be working with this simple scene in this lesson. As you can see, I have this backdrop and this artificial plant and a physical camera. To get started with the lighting, let's create a V-Ray light, and this time let's use the Create panel. So in the Create panel, go to the Light tab and select V-Ray. Now select V-Ray Light, change the type to Mesh, and click in the viewport to create the light. Now we need to tell our mesh light which is the object we want to turn it into a light source. So in the Modify panel, come down to the Mesh Light rollout, and here is where you specify that object. First, click on the Pick Mesh button and select this object that's called FR_01, which are these small yellow objects in the viewport. And now by doing so, we have turned those small yellow objects into a light source. Let's open up our render setting window, change the target to active shade mode, and make sure the render is V-Ray RT, and click on render. And as you can see in the V-Ray RT, now these small objects function as a light source. Let me stop the active shade here. Mesh light has some specific options in the mesh light rollout. First, you have flip normals, which allows you to invert the normal of the object that you have selected as your light source. Next, we have replace mesh with light, and if you kind of enable this option, when you pick your mesh, the mesh becomes a light source and the mesh object no longer will be available in the scene. Now we have the extract mesh as node, which lets us restore or recreate the object that we have picked as our mesh light source if we want to have a copy of it. Now let me go ahead and finish the lighting of this simple scene very quickly. For this first light, let's change the unit to watts and set the multiplier to something like 60 maybe. We can render the scene using the production mode. Let me stop the render and show you the render that I have saved in the frame buffer. By the way, if you want to actually store your render in the frame buffer, simply wait for the render to be finished and then click on the Save button. Here is our first render, and as you can see, it's quite nice even without having to add any more lights. Now let me close the frame buffer. Just to make it a bit more fun, let's add another V-Ray mesh light to the scene. Select the existing V-Ray mesh light, right click and choose clone. Set the object to copy and press OK. I have another object in the scene that I want to turn it into a light source. It's called vase edge. Now select the second V-Ray mesh light in the modify panel, activate the peak mesh button, and select the vase edge object. Now let's change the color of this mesh light a bit to make it a bit more interesting. Change the unit to default and set the multiplier to 1. Now take a look at the render with this new light. As you can see, because the multiplier of the second light is very low, it doesn't affect the lighting that much, but the emissive colorful object is quite eye-catching in the scene. Finally, to add a bit fill light and more color balance, let's add two simple V-Ray plane lights. Let me select V-Ray plane light in the V-Ray toolbar. Start creating the light in the left view. Now let's move it to the left side of our main objects in the top view. Now let me change the size of this light to something like maybe 85 and 75. Let's turn off our mesh lights so we can see how these extra lights are going to affect the scene. Let me run the active shade and see what we are going to get. Okay, obviously this is very bright. Let me change the unit to watts and set the multiplier to 3. Change the color mode to temperature and set the temperature to 5000 so we have a warmer light on this side. Now let's add another light to the right side. First, in the render setting window, make sure to lock the current camera so when we switch to another view, active shade still would render the camera view that we have right now. Perfect. Now select the light in the top view and click on the mirror button. Change the mode to copy and press OK. Now let me move the light to the right side and let's see what we have in our active shade. Let me change the color temperature for this light to a cooler color like 7500. And this way the warm light on the left side and the cool light on the right side will create a very nice color balance in our scene. Perfect. Now let me reduce the multiplier for this light to something like 1. Stop the active shade and let me turn on the mesh light that we have in the scene. Now we can render the scene in the production mode, or rather let me show you the result in the frame buffer. Now as you can see, our simple effective lighting is really beautiful. The next thing I want to do is to quickly prepare the scene for the final render. So let me open up the render setting window. Change the dimension to something like 1200 and 1600, or we can have a smaller or bigger render. Change the max subdivision to 100 and noise thresholds to maybe 0.006. In the GI tab, change the Irradiance map preset to medium and the light cache subdivs to something like 1000. In the render elements, let's add V-Ray denoiser and change its preset to mild maybe. Now click on the render button and wait for the results. I can show you my render in the frame buffer right now. So here is our final render, and as you can see, it's pretty clean and nice. Let me show you V-Ray denoiser pass, which helps us to get rid of high frequency noises, and we have, as you can see, this clean and amazing pass, which is really impossible to get such a clean pass with just render settings. I mean, you need to increase those render settings like crazy, the GI settings like crazy, to maybe get something close to this and wait hours and hours to for your render to be finished. but using the V-Ray denoiser pass that has been added in the Force service pack of V-Ray 3, we get this amazing clean renders basically without that much effort. Now let me get back to the RGB pass. If I zoom in, you can see the edges of our emissive objects are kind of very jagged and aliased. To counter that, let's enable the lens effect setting in our frame buffer. Let's turn on the bloom and the glare effect. Now we're going to talk about the V-Ray frame buffer and all of these, extra effects and windows in a specific future lesson, but for this lesson we're just going to quickly go over them. Let's change the weight and size of the bloom effect to 0.5 and 1 respectively. And for the glare effect, use 0.5 and 10. Now, as you can see, the results are visible in our render. And we don't see that kind of jagged effect anymore. In this lesson, we learned about V-Ray mesh light, and I will see you in the next lesson. In this lesson, we talk about another V-Ray light type, which is dome light. Dome light is often used for image-based lighting or IBL. In this popular lighting method, you take a high dynamic range image or an HDRI and use it as your light source. So when you create a dome light, you basically have a virtual spherical or hemispherical light source around your entire scene. Then you assign an HDR image to that sphere or hemisphere, and you would get a nice beautiful lighting which is based off of the color and intensity information from that texture that you have assigned to your dome light. Let me quickly show you what we have in the scene here. First, we have this clock, this bottle, and these books, and also this plane object here. Also, I have a physical camera with depth of field enabled and the exposure set to 10. Great. Let's create our V-Ray dome light. From a V-Ray toolbar, click on V-Ray dome light and then click once in the viewport. Now we have created a dome light in the scene. Always remember that the dome light encompasses the entire scene and the size of its icon doesn't matter for lighting purposes. Now select the light and rename it to V-Ray underscore dome light. In the modify panel, the first thing you need to do is to define the texture you want to use with your dome light. If you go to hdrlabs.com/sib/archive.html, you can find tons of free HDR images that you can use according to their terms of service. Now go ahead and download this lobby HDR image and put it in the images folder of your scene assets folder in your project files folder. Now let's get back to our 3ds Max scene. In the modify panel of your V-Ray dome light, click on the texture button and choose V-Ray HDRI map. Now in the choose HDRI image window, select the HDR image that you just downloaded. So basically we are going to be using all the light and colors from this image to lit our scene. Perfect. Now in order to see the HDR image that we just added to our dome light in the viewport, we need to also define it as the environment map for 3ds Max. So open up the material editor by pressing M and instance the HDR image in the material editor. I know I'm going to be using a color corrected version of this map, so for now let's connect this map to a color correction map. Right click and from the maps, general, add a color correction map and connect the V-Ray HDRI map to this one. Now press 8 to open up the environment and effects window. Instance the map in the environment map slot. Okay, now close these windows. Now press Alt and B to open up the background tab of the viewport configuration window. Set the background type to use environment background and press OK. Perfect. Now we can see the map in the viewport. Before seeing any renders, let me select my physical camera and disable the depth of field effect for now. You can now take a render and see what we have. Now I'm going to show you the render in the frame buffer. You can go ahead and continue rendering if you want. As you can see, the lighting and our beautiful reflections are all based on our dome light. One of the first things you might want to do is to rotate your HDRI map or alter its brightness, and you can do all of that in the V-Ray HDRI map. So let's open up our material editor, and also let me run V-Ray RT. We will be discussing V-Ray HDR map in detail later on, but for the time being, let's go over some of the most important options. First of all, using the horizontal or vertical rotations, you can rotate the map. So let's try 50 in horizontal rotation. Let's try 150. Maybe let's try a vertical rotation of 50. Maybe -50. Now let's change it back to 0, and let's also set the horizontal rotation to something like 250. Also, you can use overall multiplier to increase or decrease the brightness of your HDR image. Maybe let's try 3 here. Maybe 6. Now let's try something like 10 maybe. And finally, let's get back to 5. I think it would be enough for this scene. I really don't need all the color information from this map, so let's select the color correction map and desaturate it by 70. Now make sure it's the color correction map that the V-Ray dome light uses and not the original map. Now let's close the material editor and stop the active shade. Select the V-Ray dome light and see what are its options. In the dome light rollout, we have spherical, which determines whether the dome light covers an entire sphere around the scene, and if you disable it, it will only cover a hemisphere. Next, we got effect alpha. By default, it's disabled, and that means the dome light won't affect the alpha channel. In the V-Ray frame buffer, if I select the alpha channel here, you can see the light isn't contributing at all to the alpha channel. Let's enable effect alpha and run the RT. And now, as you can see, the light is contributing to the alpha channel. Next, we have lock texture to icon. If enabled and I rotate the dome light in the viewport, you can see the HDR is rotating in the render. So you can control the placement of your map this way instead of going and changing it in the V-Ray HDRI map. Let me zero out the rotation and disable this option and stop the active shade. Next, we have ray distance, which specifies the method of determining the maximum distance to which shadow rays are going to be traced. And this is the exact definition from V-Ray's help. When it's set to none, there wouldn't be a maximum distance. If set to GI, the maximum distance is determined by the GI settings. And if set to explicit, you can specify the distance using this distance value down here. Now, let me show you two renders in one the distance is 5 and in the other is 100. Let's see how it affects the shadow rays in this scene here. As you can see in the frame buffer, clearly the shadows are less visible in the version with distance set to 5. Now let me change the ray distance method to none and untick effect alpha and lock texture to icon. Then we have photon emissions options, and these two options are for when you have caustics enabled in your scene. Target radius defines a sphere around the light icon where photons will be shot, and emit radius defines a sphere around the light icon from which photons will be shot towards the target radius area. Now we're going to be discussing caustics definitely, and I'm just going to explain these options very quickly because we haven't talked about caustics yet. Let me just quickly show you how these radii affect the caustics. First, we need to enable caustics. So in the render settings window and in the GI tab, enable caustics, and just to see the effect clearly, let's set the multiplier to 30. Also in the V-Ray tab, set the image sampler to progressive and limit the render time to 1 minute. If you go ahead and render the scene, you can see after the GI calculation, we have an immediate result and it is refining as the time goes by. Now let me just stop the render and show you 3 renders that I have with different target and emit radii. Also, there are some viewport representation for target and emit radius. You can see these 2 green hemispheres in the viewport, and as I change these values, they get updated. In the first render, target radius set to 5 and emit radius set to 7, and as you can see, we practically don't have any caustics in the scene. In the second render, let's set the target to 17 and emit to 22. And now we can start to see the caustics effect. And if I take a look at my top view, you can see the green circles or hemispheres aren't completely encompassing our clock and books, and you can see that translates into our render as well. If I come here and increase the target radius to 100 and emit radius to 150, you can see now in the top viewport we have the green circles encompassing our objects completely, and this is the render you are gonna get. Now as you can see, the caustic effect is quite visible, especially inside the clock, as you can see. Let me go to the render setting and disable caustics for the moment. In the advanced option rollout, we have use MIS or multiple importance sampling. Let me go to the material editor and select V-Ray HDRI map and click on the view image button. You can see in this image we clearly have darker and brighter values. Some sections are emitting more lights and some parts are darker. When MIS is enabled, or multiple importance sampling, V-Ray will trace more rays in the direction or directions where the light is coming more strongly. You really don't need to change these options, and you'll be better off leaving this option alone all the time, but let's see a few render comparisons and see how it might affect your renders. First, go to the render setting and limit the render time to 3 minutes. In the render elements tab, let's add lighting, global illumination, and reflection passes, and press OK. These passes are essential to see what exactly MIS and multiple importance sampling are changing when it's enabled and disabled. Let's go back to our frame buffer and see 2 renders with and without MIS enabled. The first render is with MIS enabled, and in the second one it's disabled. As you can see, the results are very, very different in this particular scene when the entire lighting is coming from one V-Ray dome light. You can see we get noisier reflections, some fireflies or these very bright pixels here and there. Also, if I go to the other passes like global illumination and compare the two, you can see they have different information about the lighting. And the same thing goes for the lighting pass as well, and the reflection pass. As you notice, the lighting information is distributed differently between passes when MIS is enabled compared to when it's disabled. And now, as I mentioned, just don't touch this option and let it be enabled unless you know what you're doing. Let me turn on Use MIS again and close the frame buffer. Now let me select the physical camera and enable depth of field. As you can see, my aperture size is set to 6, so we are gonna get a very shallow depth of field. In the render setting window and common tab, let's set the output size to 1600. And in the V-Ray tab, change the image sampler to bucket. Let's set the max subdivision to 24 maybe, and noise thresholds to 0.01, and change the bucket width to something like maybe 32. This is basically the size of the buckets or squares that you see them when you render your scenes in the frame buffer. In the GI tab, set the irradiance map preset to maybe medium, and low possibly would work in the scene just fine, but and the light cache subdivs, let's set it to 1000. And in the render element tab, let's delete lighting, global illumination and reflection passes and add V-Ray denoiser. And let's change the preset to something like mild. You can go ahead and render the scene. In my case, let me just show you the result in the frame buffer. So this is our final render. And this is our V-Ray denoiser pass. Let's make some quick color corrections in the frame buffer. First, enable the white balance and set temperature to maybe something like 7000. Enable color balance and make the shadows a bit bluer, maybe something like 0.16. Also enable the highlights and make them a bit warmer, maybe something like 0.08 or 0.1 would just be fine. Now let's add some contrast using curve section. Now you can go ahead and save the result with JPG or PNG, and the color correction that you have done here would be saved. I might go ahead and do a bit more color correction in Photoshop or After Effects and save the result there too. So in this lesson we talked about V-Ray dome light, and I will see you in the next one. It's time to talk about V-Ray sun and sky. The way V-Ray sun and sky works is that it is trying to resemble the way sun and sky appear in real life. So basically, based on the position of the sun in the sky will try to adjust and mimic how the sky would look like in that specific time of day. So for example, at sunset, when sun is very close to the horizon line, the sky would be very orangish and the sun intensity and brightness would be less compared to noon, where the sun is at its highest point and the sky would be very blue and the sun would be very intense at the same time. So this real world behavior can be simply replicated using V-Ray sun and sky. Let's get into it and see how it works. As always, let me walk you through what we have in the scene. We have this tree, this bench, and hundreds of V-Ray proxies. which we'll be discussing later on, and how to kind of create VRay proxies and what is VRay proxy. But basically right now they are representing a very beautiful grass field in the scene. VRay proxy basically imports geometry from an external mesh at render time. So the geometry is not present in the 3ds Max scene and does not take up any resources. Now, that's an interesting topic for another lesson, and also we have this 3ds Max physical camera. Now from the VRay toolbar, select VRay Sun. You can start creating VRay Sun from any view that you want. I prefer to start in the top view. That allows me to decide on the direction of the sun. So click and drag in the top view. Now VRay asks you whether to add a VRay sky environment map or not, and in most cases like now you should say yes. In the front view you can decide on the elevation of the sun. As you increase its height you go from sunset basically to noon. Let me roughly position the sun in the top and the front view. If I press 8 and go to my environment and effects window, you can see a procedural VRay sky map has been assigned as the environment map, and as we see in a few moments, it takes its appearance and colors from how we position the sun in the scene. Make sure the camera view is active and open up the render settings window. Change the target to active shade mode. Lock the view to render and start the render. As I'm changing the sun position in the front view, you can clearly see how as I am getting closer to the horizon, the sun gets darker and the sky gets warmer and more orangish. And as I increase its height, we get a hotter sun and bluer sky. And as I move in between, you can see how dramatically the placement of the sun changes the lighting in the scene and affects how the sky looks. Also in the top view, I can go ahead and change the direction of the sun very easily. Perfect. Now let me put the sun where exactly I want it to be. So 6, 8, 7 on X, 6, 5, 2 on Y, and 2, 9, 6 on Z. Now let's select VRay Sun and take a look at its parameters. First we have enabled, which turns the sun on and off. As I turn it off, you can see we still have our sky and we are only turning the sun off. Now let me make sure it's enabled. Next we have invisible. Right now we can see the sun in the scene. If I make it invisible, the sun is no longer visible in this scene, but it still affects the lighting and, as you can see, produce shadows. It is just invisible to the camera and reflections. So let me turn off invisible for the time being so it's visible. Next we have affect diffuse, which determines whether the sun affects the diffuse portion of the materials or not. Then we have diffuse contribution. So if the sun affects the diffuse portion of the materials, how much it's going to be. At 1, the effect is 100%, and at 0, it's like disabling effect diffuse, and at, for example, 0.5, we are going to get an in-between effect. Let's set it back to 1 here. Then we have affect specular and specular contribution, whether the sun is affecting the specular reflection or not, and if so, by how much. So when I turn it off, you can see those visible specular highlights are gone from the grass field here. Now here, let's make sure it's enabled. Close the frame buffer window for the time being. Next, we have cast atmospheric shadows. To see the effect a bit better, let me change the position of the sun a bit. 1153 on X, 651 on Y, and 295 on Z. Also, we need an atmospheric effect in the scene. Press 8 to open up the environment and effects window. In the atmosphere rollout, add the V-Ray environment fog. Set the fog distance to something like 60 centimeters and fog height to 100 centimeters. In the render setting, make sure the sampler is progressive and set 5 minutes as the render time limit. Now let me open up the frame buffer and show you two renders with and without cast atmospheric shadows enabled. In the first render, it's disabled, and in the second one, it is enabled. As you can see, when it's enabled, the shadows are more pronounced, especially the atmospheric shadows. Now open up the environments and effects window and make sure V-Ray environment fog is inactive. Close all these windows, select the sun and put it back to where it was before. So I think it was 687 on X, 652 on Y, and 295 or 296 on Z. Maybe this time we can put it a little lower on Z so we can see the effects of parameters like turbidity a bit better. So let's set the height to 155 centimeters. And let's run the active shades again. Next, we have turbidity that controls the amount of pollution, dust, and particles in the sky. Lower values like 2 would result in cleaner sky. And as you increase this value to something like 5, you can see the sky gets more polluted. A value of 10 would make the effect to be very extreme. Let me put it back to 2.5, which is the default value, so we can get our clear sky back. Then we have ozone, which controls the color of the sunlight. By default, it's set to 0.35, and you can alter this value from 0 to 1. At 0, you get a bit more of a yellowish, orangish tone, and at 1, you would get cooler and bluer sunlight. It's a bit hard to see the effect of this parameter in this particular scene, but let me show you a few renders. In the first render, ozone was set to 0. And in the second render, it was set to 1. And in the third render, it was set to 0.35, which is the default value. If you pay attention to the grass field and also the leaves up here, you can clearly see that warmer, yellower tone when the ozone is set to 0, and it gets cooler and bluer when it's set to 1. And in the third render, we get something in between those two renders. In this case, let's set the ozone value to something like 0.1. Now let's run the V-Ray RT again. Next, we have intensity multiplier, which controls the intensity or brightness of the sun. If I set it to something like 3, you can see the sun gets a lot brighter. And if set to something like 0.2 here, it gets a lot darker. Let's set it back to 1 maybe. Then we have size multiplier, which controls the size of the visible sun. Now, to see the effect of this parameter a bit better, let's change the elevation of the sun back to 295 centimeters. Now let me stop V-Ray RT here. To see the sun disk here again a bit better, go to the render setting and in the V-Ray tab, come down to the color mapping rollout. Make sure the burn value is something like 0.2. And now we should be able to see the sun disk a bit better. So let's run active shade again. And as you can see, the sun disk is clearly visible. Size multiplier affects two things mainly. One is the size of the visible sun and the sharpness of its shadows. If I increase the size multiplier to something like 5 here, you can see the sun disk gets bigger and the shadows getting diffuser. Let's set the size to something like 10. Now even bigger with more diffuse shadows. Let's set it back to 1 so we can have our sharp realistic shadows back. Filter color changes the color of the sun based on the color mode. So when the color mode is set to filter and I alter the filter color, let's select maybe a pinkish color here, you can see the color of the sun is shifted towards this particular color. When the color mode is set to direct, you can see only the color of the visible sun disk is changing. Let's set the intensity multiplier to 0.2 so you can see the sun itself a bit better. And in this mode, the position of the sun in the sky does not affect its intensity. So if I change the height to something like 900 centimeters, even though the color of the sky has changed, but the sun has the same intensity. Let's place the sun at 295 centimeters again. The override mode is like the direct mode, but in this mode, the intensity of the sun does depend on its position. So let's set the filter color back to white and change the color mode to filter and make the intensity, maybe let's set it to 1 again. Next we have shadow subdivs, which controls the quality of the shadows produced by the sun. Now right now, if you go ahead and actually increase the subdiv parameter to 8, 64, 128 and try to see any differences in the quality of your shadows, you might not be able to kind of see that because it really depends. Whenever you see the subdiv number, it really depends on the kind of global DMC settings and sampler settings. So it's a very important discussion that we're going to be having it. But I think it's just enough for the timing to understand that by increasing the subdivs in certain situations, you are going to get higher quality shadows. Then we have shadow bias, which moves the shadow towards or away from the shadow casting objects. We worked with this parameter when we were discussing area lights, and it's exactly the same thing here. Then we have photon emit radius, which is this green cylinder in the scene and controls the radius of the area where photons would be shot when using caustics effects in the scene. This is like the target and emit radius of the dome light, and since we haven't discussed caustics yet, let's move on for the moment. Then we have sky model, which determines the procedural model to generate V-Ray sky texture. We have 4 models. I hope I'm pronouncing them the right way. We have Pritham, and we have CIE clear, CIE overcast, and Hosic. Let me go ahead and hide all the objects in the scene except for the V-Ray sun and the camera. Now let's change the height of the sun to 900 centimeters and let's go through these models again and see how they differ. Set this to Hosic and notice as I decrease the sun's elevation from 900, how the model is responding and changing the appearance of the sky. So let's try 800, 700 centimeter, 600, 500, 400, 300, 200, 100, 75. Now we are getting closer to sunset. 50, or sunrise, 25, 5, and 1. Perfect. Let's set it back to 295 and unhide everything. There isn't any rule or preference to use which model. It's totally artistic and depends on the scene and your taste. Next, we have indirect horizontal illumination, which is for legacy purposes and specifies the intensity of the illumination on horizontal surfaces coming from the sky. We have ground albedo, which determines the color of the ground in the V-Ray sky. So let me kind of hide everything except for the camera and the V-Ray sun again. And as I change the ground albedo color, you can see the color of the ground is changing in the sky model. Blend angle controls the size of the gradient formed by the V-Ray sky between the horizon and the actual sky. The default value is 5.739, and as I decrease it to something like 1, for example, this gradation becomes smaller, and if I increase it to maybe 25, it becomes larger. And finally, we have the horizon offset, and it lets you to offset the horizon. Let's set it back to 0 again. And finally, the exclude button, which works like in normal V-Ray lights. Let me unhide everything and stop the active shade. Finally, if I open up Material Editor and Environment and Effects window, we can take a look at the actual texture that controls the sky. So let me instance the environment map to the Material Editor. So this is our V-Ray sky texture. As you can see at the moment, its parameters are grayed out because they are being controlled based on the sun's position. Let's run the V-Ray RT quickly here. Now, if I enable specify sun node, I can go ahead using the sunlight option, define the V-Ray sun that I want to work with. So let's pick the V-Ray sun that we have in the scene, or it can be a secondary V-Ray sun in the scene that you have. Now I can change these parameters here. Maybe let's set the turbidity to 10. And as you can see, in real time, we can see the changes in the RT. Okay, let's set it back to 2.5 and untick specify sun node. So we are back where we were, and let's close all these windows. Let me quickly prepare for our final render. So let's stop the active shade here, open up render settings and change the target to production mode. Set the render size to 1600 by 1200 or whatever you want. Change the image sampler to bucket. Let me set the max subdivs to 50 and noise thresholds to 0.007. In the GI tab, set the irradiance map to medium and light cache subdivs to 1000. And as always, add V-Ray denoiser and set its preset to mild. Even though after the render is finished and the V-Ray denoiser takes its effect, you can actually come back. You can come back here and change the preset to other presets here to strong, for example, and hit the update button, and you can see the result immediately, which is very great. Now I have two final renders, and in the second render, the sun's position is 243 on X, 651 on Y, and 59 centimeters on Z. Now let's take a look at the results. This is our first render, quite beautiful and gorgeous. Let's do some quick color corrections here. Maybe open up corrections control, enable white balance, and let's make the scene a bit warmer by casting out some blue. Maybe 8500 would do just fine. This would be enough, but if you are looking for more of a dramatic effect, let's enable color balance and enable shadows and make them a bit bluer, maybe about 0.15. Select the highlights or enable it, and let's make the highlights a bit warmer, maybe negative 0.5. Then we can go ahead and save your render. And for the second render, let's just enable the white balance and make it a bit warmer, maybe 7700. And I can save this render, I guess, right now. We can continue with the color correction and save another version later on, but right now this is a nice render. Let me enable curve correction. Now let's try replicating a classic sunset shot. Select the first point and try lowering its tangents until you get a silhouette of the foreground objects, and this would be a nice render too. Perfect. Finally, let's open the lens effect setting. Make sure you enable these effects before hitting the render, or you would be forced to re-render to be able to kind of see how these effects affect your render. Uncheck interactive and enable bloom and change its weight and size to 2 and 20. Enable glare and set its weight to 3 and size to 15. And now you can click on the update button. There you guys, you can see very beautiful sunset image. Maybe you can go ahead and actually do the same thing in Photoshop, and you can work on it as you wish. So in this lesson, we discussed V-Ray sun and sky, and I will see you in the next lesson. In this lesson, we cover V-Ray IES light. IES light is a photometric light that contains the distribution profile for the light provided by the manufacturers. So basically, using this light type, you can resemble lighting fixtures and produce complex distribution patterns without having to model the fixture or the lamp. So this is the scene we are going to be working with, the same scene we had when we were discussing skylight portal. I've just changed the camera angle and added a few furniture. Before getting into it, one thing I want to mention is that I compose these shots to specifically work with the current topic. So basically, this camera view that we have in the scene is the only one that's going to work. Notice I have these recessed lights in the ceiling, and what we are trying to do is to create our IES lights based on the position of those recessed lights. Now from the V-Ray toolbar, click on V-Ray IES, and in the front view, here is where our first recessed light is located. So let's try to put the light just slightly under the lamp and drag to create its target, basically where the IES light is going to point at. Now select the light and its target, and in the top view, make sure they are right under the recessed light. Select the light itself, and in the modify panel, the first thing you need to do is to define the IES file or that specific distribution pattern of light that you are interested in. So click on this button to define the IES file. You can simply Google IES files and download thousands of free IES files from manufacturers' websites, and use a simple software like a photometric viewer to actually see how they look before using them in V-Ray. In this case, I've provided two IES files that you can find in your project files folder, screen assets, and photometric folder. For starters, let's use this complex IES file, which, as the name suggests, it has a bit more complex distribution pattern compared to the simple one that we have here. Perfect. Now let's go to the render settings and change the target to active shade and make sure V-Ray RT is your render, and also lock the view to render to the physical camera 001. And let's start the active shade. First of all, I can select the target and point the light to any direction that I want. Now select the light, and in the modify panel, let's take a look at its parameters. Using enable checkbox, you can turn the light on and off. Using enable viewport shading, you can see the effect of the light in the viewport if a higher quality viewport is activated, obviously. Next we have show distribution, and when enabled you can see this mesh around the light that represents the distribution profile for this particular IES file. Next we have targeted, which allows the light to have a target to make pointing the light at a specific direction easier, and we used it a few moments ago. Then we have IES file, where we can define that particular IES file that we want to work with. Next we have rotation X, Y, and Z, and we can simply rotate the light in different directions using these values here. So let's try rotating the light on X by 5-degree increments. Also, you can use negative values here. Let's try Y rotation. Now in this case, Z rotation or Z direction wouldn't do much. Then we have cutoff, which is a threshold below which V-Ray stops computing the light. Let's try 0.4. Now let me set it back to its default value of 0.001. Now let's stop the active shade and let's change the IES file to the simple one. Also in the render settings, let's untick override material and run the RT again. Shadow bias move the shadows produced by this light away or towards the shadow casting objects. Then there is cast shadow, which allows you to enable or disable shadow casting for the light. Next we have affect diffuse and diffuse contribution, which controls whether the light affects the diffuse portion of the materials or not, and by how much. Then there is affect specular and specular contribution that lets you decide whether the light affects specular reflections and basically by how much also. Now let me enable override material again to get faster feedback. We have use light shape. Here we can decide on how the shape of the light is going to affect our shadows and illumination. If set to no, you can see we get very sharp shadows, and that is because when set to no, V-Ray considers the light to be a point light. And as we learned earlier, the smaller the light source, the sharper the shadows, and that's why we get these very sharp shadows in the scene. If I set it to for shadows only, the shape of the light indeed affects the shadows, and as we can see we get diffuser shadows, but the overall illumination will not be affected. And if set to for illumination and shadows, the shape of the light will affect both the shadows and the overall illumination. Let's set it to for shadows only. Next we have override shape, and if enabled, the original shape of the light will be ignored and you can specify other shapes to be used. Now remember, these shapes won't affect the light distribution, it just changes the way our IES light handles the shadows and overall illumination. Let me change the shape maybe to a sphere. Now if I set the diameter to something like 1, the shadows will be very sharp. And as I increase its diameter, the shadows are getting diffuser. You can use different shapes, and height, width, length, and diameter parameters can be used to control the exact dimensions of your specified shape. Here, let me change the shape to point and disable override shape. Next, we have shadow subdiv. As you increase it, you're going to get higher quality shadows, but it also depends on your image sampler and global DMC settings that we are going to discuss it later on. Then we have color mode, and it works like normal Viri lights, right? Next, we have intensity type, which is the unit to control the light's brightness. We have power that controls the intensity of the light in lumens, and intensity that controls it in candelas. So let me set it back to lumens here. We have intensity value. Obviously, this controls the overall intensity or brightness of the light. Let me set it back to 4850, which is the default intensity for this particular IES file. Then we have area speculars. If you disable it, the IES light will be seen as a point light in the reflections of our materials. The rest of the options are having the same functionality as other Viri lights, and we discussed them in previous lessons. Now let's go ahead and finish the lighting of the scene and prepare the scene for the final render. Stop active shade and close any active window. Select the IES light and its target. Start copying the light and its target to other recessed lights that we have in the scene, and make sure you set the mode to instance, so altering one light would affect the rest. Now, as you can see, I didn't cover the entire room. That's because, as I mentioned at the beginning of this lesson, I'm composing and lighting my shots for the specific camera that I have here. But if you like, you can go ahead and add more lights to the rest of the scene, and maybe add more furniture and render other angles. Open up the render settings and enable override material. Now let's run RT and see what we have. Perfect. Let me stop the render here. That is a good starting point. Now I'm gonna add a few area lights to the scene to make the lighting a bit more realistic. So let me select Viri sphere light in the toolbar. And in the top view, let's add the light. Now move it up in the front view. Create 2 copies from this light and distribute them in the room. Now select one of the lights and change its radius to 15 centimeters. Set the unit to watts and change the multiplier to 25. Also set the mode to temperature and use 5000 as the volume. Now let's run the active shade again and see what we have. If I turn these sphere lights on and off, you can see how they affect the lighting. Now in V-Ray we have a material called V-Ray Light material. We discussed V-Ray Mesh Light a few lessons back, and when you apply V-Ray Light material to a specific object, it turns that object to a self-illuminated surface. So let's create a V-Ray Light material and apply it to our recessed lights as well. In the material editor, right click and add a V-Ray Light material. Set its multiplier to 10 and enable direct illumination. Now I have renamed the parts of the light that I want to apply this V-Ray material to light MTL, just so I can be able to select them easier. So type light MTL in the Explorer and press enter to select them. Now assign the material. Also, if I open up my environments and effects window, as you can see, I have this gradient ramp as the environment map, and if I instance it in the material editor, you can see it's a very simple map. Now let's make sure the override material is disabled in the V-Ray RT settings, and let's run the active shade again. Okay, perfect. Also, I think the scene is a bit dark, so let me select my camera and reduce the exposure value by 1 stop, so the camera would let a bit more light in. Now, perfect, that's a lot better. Let me stop the active shade and let's enable lens effects in our frame buffer before the final render. Now let's open up our render settings window, change the target to production rendering mode, and in the common tab use 1200 and 1600 for width and height. In the V-Ray tab, change the max subdiff to 50 and noise thresholds to 0.008. Also, let's make sure local subdiffs is turned off. Now in the GI tab, set the irradiance map preset to medium, set the subdiffs to 70 and samples to 25. And in the light cache, increase the subdiffs to 1000. Also, let's add V-Ray denoiser in the render elements and change its preset to mild. Now you can go ahead and start the render. Now in the frame buffer, this is our final render. Let me make sure bloom and glare effects are off. Open up the corrections control. Let me enable curve correction and maybe add some contrast. Finally, let's enable bloom and set its weight to 4 and height to 20. Also enable glare, set the size to 10 and weight to 20. Also, this is our denoise version of the render. Now you can save these renders out and you are good to go, and maybe color correct them in Photoshop if you like. So in this lesson we learned about V-Ray IES light, and I will see you in the next lesson. In this quick lesson we are going to discuss V-Ray ambient light. Ambient light is a very simple light that adds an even amount of illumination from every direction. So it's not coming from any particular direction, and also it can be used to create effects like ambient occlusion. Now for this lesson we are going to be using the same scene that we used for the previous lesson, which was about IES light. So open up 0206 underscore V-Ray underscore IES light from your project folder, and let's continue. As this scene has no light, let me add a very simple sphere light. Set its radius to 15 and unit to watts, and make sure the intensity is about 20 watts. Now we can run V-Ray RT. From the V-Ray toolbar, let's select ambient light and add it anywhere in the scene, as the location and orientation of this light does not matter and it doesn't cast shadows. So the light doesn't cast shadow at all. You can put it wherever you want and the result would be exactly the same. Now let me select the ambient light and let's take a look at its parameters. First, you can turn it on and off using enabled option. Using color, you can define the color of the light. Now let me set it to this purplish color. Intensity controls the overall brightness or intensity of the light. So if I set the intensity maybe to something like 0.1, you can clearly see that we can simply add a tint of any color to our render using ambient light. Let's set the color to the default gray and set the intensity back to 1. Using light map, you can use a map or a texture to control the color of your light. Let's maybe use a checker map here, and you can see the results in the VRT. Okay, let me clear the map and turn off light map. And obviously using this value that you have beside light map, you can mix the texture with the color up there. So at 100%, at 100 you are only using the texture, and if you use something like 50, you're going to be using 50% of texture and 50% of the color, and mix those two together. Next we have compensate exposure. If you enable it, the defined color here will not be affected by the camera's exposure. Let's select the color here, whatever color, it doesn't matter really. At the moment, compensate exposure is turned off, so if I select my 3ds Max's physical camera and try increasing the exposure value and therefore letting less light into the camera, you can see that color also gets darker and darker. But if I select my ambient light and enable compensate exposure, now you can see the color is back where it was, and if I select my camera again and alter the exposure, you can see that color is the same and the exposure value of the camera is only affecting the rest of the scene and not the color. Now let me set the exposure to 8.5 and select the ambient light again, and let's set its color to the default gray value. Now for the time being, let's set the GI minimum distance to 10 so we can see how this light tries to give us a fake GI or an ambient occlusion effect. Ambient light has 3 modes. When set to direct and GI, the light affects both direct and indirect illumination or indirect lighting or GI. So if I set the mode to direct, the light only affects direct lighting and adds a constant color to the scene. And if set to GI, it only affects GI or indirect lighting. Now GI minimum distance, if I quote Chaos Group, basically it specifies a distance from objects within which the GI rays will not be affected by the ambient light. As I increase this value, you can see how it works. Now let's set it to 10. If I now change the color to pure white and increase the intensity to maybe 5, we would have a proper ambient occlusion path that can be used in compositing to add a bit more detail to the render. Even though there are easier ways to render out an ambient occlusion path in V-Ray, but that's how you do it using an ambient light. In this lesson we talked about V-Ray ambient light. I will see you in the next lesson. In this lesson, we are going to talk about 3ds Max's light compatibility with V-Ray and basically how 3ds Max lights can be utilized in V-Ray. First of all, I wouldn't recommend using 3ds Max's lights with V-Ray even though they work, but always remember that V-Ray lights are optimized to work with V-Ray and almost all the time will give you better results. Let's start with 3ds Max's daylight system, which can easily work with V-Ray, and it offers some features that V-Ray sun and sky system does not. For this part of the lesson, I'm going to be using the scene from the lesson that we talked about V-Ray sun and sky. So open up 0205 underscore V-Ray underscore sun underscore and underscore sky underscore start dot max. Now in the Create panel, select Systems, and from the Standard section, you can choose Daylight. In the top view, click and drag to create the system. Release the mouse and move your mouse to position the sun. Perfect. And now you have created a daylight system. Now you need to define V-Ray sun and sky as your sunlight and your skylight in the daylight parameters. Go to the modify panel in the daylight parameters. Select V-Ray sun as your sunlight. Now, like when we were adding a normal V-Ray sun, V-Ray wants to add a V-Ray sky map to the environment too. Let's say yes. Now, if I run the RT, you can see we have a V-Ray sun and sky. Now I can change the position mode to manual and start positioning the sun exactly like I would have done it if it was a V-Ray sun, and the results are exactly the same. Great, let's stop the active shade. I can change the position mode to date, time, and location, and now if I click on the setup button, I can set the time, date, and location, and V-Ray will automatically position the sun to be in the proper direction. Let's change the month to maybe September and time to 6:30 a.m. Now, if I run the active shade, the sun is positioned based on those data. If I get back to the modify panel, we have V-Ray sun parameters rollout, and you can control all the aspects of the V-Ray sun and sky like you used to. So that's how you can use 3ds Max's daylight system with V-Ray. Next, let's talk about other 3D Max lights and see how they work with V-Ray. For this part of the lesson, I'll be using the scene from the first lesson of this section. So open up 0201, area lights, plane, disk, sphere, start.max, and let's get started. From the Create panel, go to the lights and choose Standard. Obviously, mental ray lights are out of question as we are working with a different render engine. Also, V-Ray doesn't support skylights, but you can safely use spot, direct, and omni lights. In this case, let's select target spotlight and start creating the light in the top viewport. Now you can move the light up in the front view. In the render setting, make sure active shade is active and the output size should be square, maybe 500 by 500 pixels, and let's render the scene. Now select the spotlight and let's see what we have here. The first thing you need to do is to make sure your light has proper V-Ray shadows. In the shadows option, you can see we have two V-Ray options, V-Ray shadow and V-Ray shadow map. V-Ray shadow is capable of producing realistic shadows, and shadow map produces mapped shadows, which is a bit more traditional method, and I don't think there is any need to discuss it in this series. So let's set V-Ray shadow as our shadow type. In the spotlight parameters, let's set the hotspot to 10 and fall off to 15. Also in the intensity rollout, set the multiplier to something like 20. Right now, even though we have selected V-Ray shadows as our shadow type, but as it's obvious from the RT, the shadows are very sharp and unrealistic. You need to come down to V-Ray shadow parameters rollout and enable area shadows. As you can see now, the shadows look a lot better. Now we can decide how the area shadows are going to be calculated. We can choose box or sphere. If set to box, V-Ray will assume that the light source has a box shape, and using U, V, and W size, you can change the dimension of that assumed box. And as you make the box bigger, the shadows are going to get softer and diffuser. Also, you have sphere, and if set to sphere, now V-Ray will assume that the light source has a spherical shape, and in this case, U size controls the radius of the sphere. For the omni and direct lights, you would get the same option like spotlight, so I think that would be enough for this lesson. So in this lesson, we learned about 3ds Max Lite's compatibility with V-Ray. I'll see you in the next lesson. In this lesson, we are going to be talking about one of the lovely lighting tools in V-Ray, which is V-Ray Light Lister. As the name suggests, the tool allows you to list all the lights in the scene, both native 3ds Max lights and V-Ray lights, and also lets you control the most important features of any light in the scene in a convenient location. We are going to be working with this scene, which is from the mesh light lesson. I just added 5 more lights behind this main object, and they are instances of each other. So let me run V-Ray RT and open up V-Ray Light Lister. You can see we have all the lights in the scene in one convenient place, and we can control all the important aspects of our lights very easily. First, you can select any light using this light selection box. Then you can turn your lights on and off. Let me turn all of them off. Now let's start with the right light, which is light number 004, and turn it on. Then the left light. Now we can turn our mesh lights on. And finally, let's turn our background lights on too. Next, we have the name of the lights, but in case of our background lights, as they are all instances of each other, that's why we get this drop-down list, and we can select them individually if we want. And then you get all the familiar light properties like multiplier, color, temperature, unit, shadow casting, invisibility, and the rest. It's extremely useful to control your light using Light Lister, especially in the scenes that you'd be forced to deal with tons of lights. So instead of going through the scene and selecting them and modifying them individually, you can simply open your Light Lister and run V-Ray RT and start adjusting and altering your lights and your lighting. Now up here in the configuration rollout, currently we have all lights enabled, and that's why we get all the lights in the scene. If I turn selected light, you can see only the selected lights in the scene will show up in the list. If you have created any specific selection sets of your lights, you can enable selection set and choose your selection set from this dropdown, and only the lights in that selection set would show up here. You can refresh the list using this refresh button. So if you added a new light to the scene or deleted one and it didn't show up here in your light lister, you can press refresh and those changes will be updated in the list. And if you enable general settings, you can kind of control some of the light parameters globally. For example, you can tint the color of all the lights. Let me just stop RT here, because sometimes these tint color won't show in the RT. Let me just choose this red color here and run the RT again. And as you can see, all the lights are getting this red tint here. Or using global level, I can make all the lights in the scene twice brighter if I use 2 as the global level. Now let's set it back to 1 and change the global tint to white again. So that's about Fury Light Lister, and I will see you in the next lesson.